Thank you, guys. Okay, much uglier slide. Right, so I prepared a talk about time zones and schedules in general. There are some Go examples, but this is more high-level conceptual kind of talk. But yeah, this month is month of October, so a very special month. I came in a Halloween costume. And this week is actually also a very special week because the clocks are going forward, right? At the end of this week. So yeah, very topical schedules. Here's the context of why I am talking about this. I work at Dexory, which is a company that works with robots. They had, at the time when we were starting the scheduling project, they had over 50 robots. This is how these robots look. They sort of drive around the warehouse and scan all the barcodes on the shelves, and then that creates visibility for customers in where all these products are. All these robots operating in warehouses across the world, so in the UK, in Europe, in the US, already adds complexity regarding time zones. On average, scanning once a day. So usually during the night, the robot goes out of its dock and goes around the entire warehouse. Actively scaling. So it was 50 robots, now it's almost 100, and we will continue scaling, hopefully to many other hundreds. And we also wanted to put a very big emphasis on customer satisfaction. So avoid making mistakes, running the robots out of the agreed time, things like that. And at that point, we were operating with the remote support team, which this team was following the schedules that were agreed with customers and manually starting and stopping the robots at those agreed times. And then the same team would be resolving any issues, such as robots getting stuck and stuff like that. So obviously, with scaling, we would not be able to go on this way with people manually starting, stopping all the robots, so we had to implement a scheduling system. Some context, what software we already had. So we had Robot Manager running on the robot. That's the stuff that kind of allows you configuring everything on the robot, allows you to control the robot, to start and stop the scans, and gives you very detailed visibility for what's going on with the robot. You can see its camera feed, you can see how the scans are going, where the robot is on the map, and stuff like that. And then we had Fleet Manager running in the cloud and giving a high-level overview of all the robots and giving visibility for a smaller subset of the most important info, such as whether the robot is docked or not, is it charging, what's the charge level, is it scanning right now, stuff like that. And this is what we wanted to get to with Robot Manager running on the robot and allowing to configure schedules for this robot. And then Fleet Manager should allow viewing all robot schedules in one place, having this high-level overview of where all the robots are. Main goal being to eliminate the need to manually start and stop robots every day. And this is sort of already spoiling the end results, but for Robot Manager, this is kind of the way we wanted to see it. You can configure schedules. It will show you exact time intervals that the robot is using internally to decide when to scan. So it was very important for us that whatever is showed in the UI actually aligns with the real underlying logic. Not having to worry about time zones, daylight savings, and other tricky things. So, making sure that the system is easy to use and scanning strictly within the configured times. And for Fleet Manager, this is the high-level overview we wanted. Main goal to just display schedules, showing once again the exact time intervals, not having to worry about time zone stuff, and refreshing info as soon as it's updated on the robot, which is out of scope for this talk. Now, terminology, what things there are. Events, I will say event, and I will mean start and end time, and potentially recurrence rules. So it's just the stuff that you have on your Google Calendar. You can configure a recurrent event, you can configure a one-time event. That's the specification for the event. Event occurrence is the actual calculated occurrence of an event. So, for example, you can have an event starting on the 1st of the month. It occurs every day. That's the event itself. And then its 10th occurrence will be on the 10th of the month. And our rule or recurrence rule is the thing that specifies how the event should occur every week, every day, every month, stuff like that. Then question, how long is an event? If I configure an event to happen from midnight to 3 a.m. and it happens every day. So what do you think, guys? 3 hours? Any other question? Any other answers? 4?
Could be plus minus a second depending on leap seconds.
That's a very good answer. Plus minus second depending on leap seconds. So we've got 4, 3, 2. Yes? If you have a time change, it will change. Yeah. So there's a lot of, it's a trick question. There's a lot of stuff that can happen that can turn an event that's running from midnight to 3 a.m. to something completely different. And this is how I kind of visualize it in my head, that on usual days you just have, midnight, 1 a.m., 2 a.m., 3 a.m. In between of each of these points, 1 hour passes, and Google Calendar is behaving like, normally, nothing unexpected. But then we have the upcoming date, 26, where the clocks are going forward. Therefore, the event ends up becoming 2 hours instead of 3 hours. So on the left, I visualized it as sort of passing 1 hour, skipping 1 hour, and then passing 1 hour again. And the way Google Calendar shows it, it shows the end time in the sort of time zone of the start time. So it shows the real length of the event. It shows 2 hours when in reality it actually finishes at 3 a.m. but 2 hours passes. So it's kind of weird. And then another case where the time goes back. So you pass the first hour, you pass the second hour, then you pass the second hour again, and you pass the third hour. So that ends up being 4 hours, and Google Calendar shows 4 hours instead of 3 hours for this recurring event. So all of these kind of crazy things, we really needed to be sure that we get those right, and we don't create like unexpected situations where robots are driving out of their dock and scanning in a warehouse when the client is not expecting that to happen. So that was really, really critical. And yeah, these are all the different kind of things that become challenges when working with time zones. It's different offsets relative to UTC. So some places are +0, +1, plus integer number of hours. Other places like Nepal have +5 hours, 45 minutes, and many, many other variations. Then there's different daylight savings rules. Some places don't do daylight savings, some places shift by 1 hour back and forward. And there's one island in Australia that shifts by 30 minutes. That's the only place in the world that does that. And yeah, we had to consider this question, what do we do with that island? How likely is it that we deploy a robot to that island? And we decided we're not going to probably deploy a robot to that specific island in Australia. But yeah, then you have different days when DST starts and ends. For example, UK and US differ by a week for when the clocks go forward and back. You have special events like sleep seconds, stuff like that. And all of the above changes over time. So some countries start implementing new rules. The government changes, they decide to abolish DST, and then you have to keep on top of that. So yeah, with all that considered, what are the actual challenges practically that we ran into when implementing scheduling on robots? The first one, obviously conversions between time zones. Because the robots can be in the US, we are in London, we're the support team, and we want to know when the robot is running according to our time. So this actually is resolved fairly straightforwardly because there's so many tools available. Many very smart people did the hard work of creating a database of all the time zones, all the time zone rules, and making that available through packages. Then these packages are being used by standard Go library. So all of that is already thankfully covered. Then some examples for that part. We have the standard time package in Go. The most used functions for the scheduling functionality was load location, which allows you to sort of load the location object, giving it a string, such as Europe/London. It will load the London location, and then it can operate times according to London rules. Then parsing location allows you to parse a specific timestamp as if sort of interpreting it as if it's in that location. So you give it, for example, 26th of October, 1 a.m. You tell it that the location is London, and then it will consider it to be tied to the London time. And then there is the function that can switch the time zone from the one that is currently tied to the time to your target time zone. So for example, if you have time in London time, you want to convert it in UTC, you put your time variable .in time.utc, and then you get the converted time in UTC. You can print it as a string or do whatever you want with it. And another very, very helpful library was rRuleGo. This library helps with calculating recurrence rule. So calculating schedule occurrences from recurrence rules. The first and last functions is just converting a string to a recurrence rule and converting the recurrence rule back to string. So just kind of conversion. And the middle function is the most interesting. It allows you to give it a recurrence rule and calculate all the occurrences of the event in between 2 points in time. The downside of this, though, is that it only works for one timestamp, so you give it a start time or you give it an end time. You cannot give it a whole event. So it's kind of up to you how you implement that logic of how you calculate end time from the start time or stuff like that. And just a quick example, because I wanted to include a Go example in this talk. Here's how you can use the time library in Go. You can load location America, New York. Let's say this is the location of the robot itself, where robot is driving around and scanning stuff. Then you can give it some date time, and you can say, please parse this date time, assuming that it is relative to this location. And then you can, on the bottom, assume that the user is in Europe, London. You can parse that as a location and convert the event start time to user location. And then you can format it in whichever format you want to see it in, in the API. So that sort of covers all these tricky parts of converting between time zones, calculating occurrences. There's a lot more to it. As I said, the start and end time of the event, the way you pass that to the library, you can do it different ways, but I won't get too much into detail. The point is there's just a lot of tools already available and good to make use of them. Then the next problem was ensuring that robots never overrun the end time. And that was also related to the way we work with these libraries, the way we calculate the end time of the event. So we decided instead of using start time and duration, we would use start time and end time and ensure when calculating occurrences that we never end up actually overrunning the end time. And that required some custom logic. So yeah, that's something to be aware of. Then ensuring that robots follow their local daylight saving rules. There was a very strong temptation at the beginning to say, hey, why don't we just configure all the schedules in In UTC, it's so simple. There's no weird switches, daylight savings. It's easy to convert from to UTC, and everyone will be happy. But no, that was a trap, because if you configure all the schedules in UTC, but then the robot is actually in London, and then suddenly London switches time, and then the robot should be starting later by 1 hour or sooner by 1 hour, UTC cannot help you. So you have to store schedules in the time zone, the rules of which should actually apply to the occurrences of these events. Long sentence, sorry. Then next thing, ensurance that we see exactly what the robots will do. So we were really, we wanted to be really careful about seeing the things in front end exactly as they are calculated in back end. Obviously, front end, TypeScript, whatever, there's loads of libraries that can do the same things, that can calculate event occurrences, show it on the calendar. But because for us it was so important to show exactly what's happening on back end, we ended up making the choice to calculate occurrences on backend, return that to the front end, and then show just the occurrences. And then schedule editing meant you pass the event itself, the event object itself, the front end can edit it, but in order to render the event occurrences, the front end would have to consult the backend. So yeah, that's a tricky part as well. Depending on the needs of your system, you may need to think about this. The next thing, respecting how time zone rules change over time. I don't know how important it can be in different scheduling situations, but if you need to stay on top of it, just make sure to update relevant packages in time. For us, we sort of just assume that historical changes and really short notice changes are out of scope, so that wasn't as big of a concern. But yeah, it's one of the consideration. And thorough testing. You really need to think hard in this case what you need to test. So cases like the schedule starts in summer, repeats all the way until winter, and we need to check if the winter events are showing as we expect. Edge cases on the borders of daylight savings, conversions between time zones with different DST, daylight savings switch dates, and verifying that the UI is reasonably aligning with the backend. That was our concerns when testing, but for you it may be something else or subset of this. Yeah, just to share the general shape of the system, we have all the different robots running. Each robot has an application called Robot Manager on it, which has its own UI, backend, /API, and the database. And we have Fleet Manager running in the cloud. Fleet Manager pulls information from the robots by communicating between Fleet Manager backend and Robot Manager backends. And just to generalize it and reduce noise, let's call it Robot N and start from this diagram. So yeah, on the robot itself, we will store events in the database, including the recurrence rules, so the specifications of the events. Then the backend API part, the backend can calculate occurrences, and API can return these occurrences to whoever needs them. And front end can show occurrences, but allow still editing underlying events. And then in terms of getting visibility for all the robots, Fleet Manager can pull all the time zones and schedule occurrences from different robots. Here is a caveat that you cannot pull schedule occurrences for infinite time. You have to decide what time interval is enough for you. So we decided like -7 days plus 30 days. It's enough to know ahead of time in 1 month ahead of time what our schedules are. And then in Fleet Manager, UI can convert to users' local time and show the schedules in a way convenient to the user. And this is the end result. A bit more details about how it actually ended up working. Obviously, much more work was put in from the UI side. So, Go is just the engine that was running all the schedules. But we added the editing for this events. You can add an event, specify start end time, select the kinds of actions for the robot to do during that time, specify recurrence, save the event, and then you can see this lovely pop-up. This allows you to see the same timestamp, but in different time zones that we care about. So we care about UTC because all our logs were in UTC. We care about the robot's local time zone because that's what the customer understands, and we care about user's time zone because that's what you understand very easily. And then you can edit recurring events really easily. You can edit one instance or this and future instances, basically similar to Google Calendar. And then each robot has a bunch of system settings. One of them is robot time zone. And if you want the robot to operate by America Phoenix rules, you set America Phoenix there. If you want the robot to operate by London rules, you set London there. And all the event times that you specify here are interpreted relative to that specific time zone. And this is how you end up seeing the events in Robot Manager. You can switch between the robot time zone, user time zone, and UTC, and you can see like switching between London. London shows you that the time ends up switching because London clock is switching. But if you look at the same schedule in UTC, you'll see that in UTC it's actually the same. And yeah, this is we've already seen this, but the same thing in Fleet Manager, where you can hover over time and see what is this time in different points of reference for UTC, the robot itself, and your local time. But the overall schedules this overall schedule is obviously displayed just in your local time because there's so many robots that are all in different time zones that there's no way to unify that in a reasonable manner. And these are sort of the learnings, the questions I would consider if I was implementing a scheduling system in some other context. Point one, which way of storing timestamps makes sense for your situation? So, for example, the time zone setting, does it make sense to store per event or per the whole device? For us, it was per device. Do you want to store timestamps without time zones to be easily interpretable in different time zones? That's what was right for us, but maybe you don't want that. Or do you want to store timestamps together with the time zone to ensure consistency of how the timestamps is interpreted? That's, I think, what Google Calendar does. So if you export and import events from Google Calendar, it will not suddenly, mess up the real event times. Which time zones do you need to convert between? Which time zones do you care about? So for us, it was user's local time, so the person looking at the UI, robot's local time, because that's where the robot is, that's where the client is, and UTC to correlate with the logs. But that's a good question to ask because maybe it could be different for you. DST rules of which time zone should apply to your events. That one was tricky to figure out. That's where I said the temptation to just use UTC is very high. So that's the question that would sort of hint you to think about it deeper. Where should occurrences be calculated? Backend, frontend, or both? If you don't care that much about whether they align or not. And which existing libraries can you use to make your life easier? There's a lot of ready solutions out there. Then what do you need to preserve for recurring events? Duration or the end time? For us, it was the end time because of agreements with clients. And for your system, how critical is it to stay up to date with the new time zone changes? So that's the question around how often should you update your packages? And then what cases do you need to test or unit test to be confident in your system? So yeah, all of this I would consider if I was re-implementing a scheduling system in another context. I think that's it. Thank you.